Hey there, CS210 students. So let's talk about Chapter 3. This is Part 1 of the overview. And in this Part 1, we're going to talk about decision structures. So in your previous programming classes, you would have written decision structures where you wrote if or if-else conditions. So let's talk about the syntax in C++. For those of you that have a Java background, you'll find that this is very similar. So the format for an if statement is if, and then the tested condition. And unlike in Python, just like in Java, the tested condition has to be wrapped in parentheses. So if you don't wrap it in parentheses, you're going to have a syntax error. So we go if tested condition, and then immediately open up a curly bracket, and then inside Visual Studio, press Enter key, and it should automatically close it for you. One of the things that we'll see in this section is that a common mistake is not wrapping the entire block of code that you want to execute based on this condition inside the curly brackets. So get in the habit immediately, type if, the condition wrapped in parentheses, and then open and close the curlies and write your statements in here. So remember, the logic behind these if statements is that if this condition is true, then we will execute whatever is inside this block of statements here. So in this case, the user age that they type in at the console has to be greater than 65. So keep in mind the logic. So if it is 65, that's not greater than 65. So you would have to go to the next number, and it's an integer. So we already declared as an integer, so the first valid value for this is 66. So anything 66 and above, this is going to trigger and execute. Anything less than 65, including 65, is not going to execute. So we continue scrolling down. So in addition to the if statement, typically we write an else block. So we know that the first condition is anything that executed when this statement is true. And then the else block is everything else. So this would be the second branch. So if we had above the user is greater than 65, down here, this would handle the case of the user being 65 or less. And just like we talked about with the if statement, you need to wrap the else block in curly braces. So type else, open the curly, close the curly, and everything goes inside here. So we can see that in action here. So they're saying if user age is less than 25, then we have an insurance price. Otherwise, we get an insurance price of 2,200. So for all of you that are less than 25, I apologize. Your insurance is more than double of what those are that are 25 and older. But in the code, you just have to deal with it. So we can have multiple else if statements. So we can say if, and then the tested condition, and then we have an else if. This would be the next tested condition. And we can have as many else if statements as we like, and then we'll terminate it with an else block. So this is how you set up the logic in an application. So keep in mind that the logic has to be true. So if you have something that covers something that you want to test later on, you probably don't have the right logic. So make sure that you're testing the logic in the right order. So typically, we can use the equals. So we're checking if two things are equal in an if statement. So we do that by using the double equal sign. So we can come down here and we say if number of years is equal to 1, then you're a first year person, great. Otherwise, if it's equal to 10, then we say a whole decade. And so you can see that they're checking it against a value using the double equal sign. So again, they talk about some common errors here. And again, when a branch has a single statement, the braces are optional, but good practice, you always use the curly braces because later on, you might have forgotten that you didn't put the curly braces and you're trying to figure out why something's not executing. Well, just do it from the beginning and you can eliminate this from the start. Okay, let's go on to the next section we'll talk about. This is 3.3. So again, we're talking about if-else statements, and in this section, we're talking about where we nest an if statement within another if statement. So this is the idea of known as nested if statements, and so we have in here, we check if the user choice is 1, great. If it's 2, then we come in here, and so number of items might also be some input that they typed in. So we check if the number of items is 0, which would probably mean that that's a mistake, right? You can't have negative number of items. So we would potentially prompt the error message here and state, re-input number of items. And then in the else block, we know that the number of items is either 0 or more. So this is probably the valid case for that. So keep in mind, you can have if statements within if statements, and that's perfectly fine. So they also show in here that you can have completely separate if statements. So for instance, they come in here and you enter in the user's age. And so if it's less than 16, we say enjoy your early years. If you are older than 15, then you are old enough to drive. If you get greater than 17, then you are old enough to vote. Greater than 24, then most rental car companies will rent to you. And if you're greater than 34, you can run for president. So a couple issues that I have with this. Number one is if they're checking if you're older than 15, then that means you have to realize as you're reading this code that they're meaning that you have to be 16 or older. And correct me if I'm wrong, but in most states that's the case. So why wouldn't they just write this with a greater than or equal to 16? So that's my first beef. Down here, same idea. We've got greater than 17, which means you have to be 18 or older. So shouldn't they have probably written this as greater than or equal to 18? So my first beef is if it is a number, a value that is a delimiting factor. So a choice has to be made because you are 18. Then I would prefer it to be explicitly stated greater than or equal to 18. And all of these fit that criteria. Secondly, the other thing is, so while we can print everything out, so this is a case where, hey, if you're 99, well, you're old enough to drive, you're old enough to vote, car rental companies will rent to you. Not sure you should be getting rented a car at 99, but hey, that's okay. And then you can also run for president. Again, I don't know if we want 99-year-olds as president, but they can do those things. So for this example, yeah, that's fine. But typically, if you're going to have multiple conditions based on some numeric value, so like an age here, we would typically write this with an if, else if block. That would be if we just wanted to have one choice. And kind of typically in a decision structure, we want to have one choice. Okay, let's go to the next section, 3.4. And so those tested conditions that we can write with an if statement, we've already seen that we can check if two things are equal. That's using the double equals operator. We can also check if two things are not equal. So this is the exclamation point equal. So this is not equal. But we can also use other relational operators. So we can use greater thans, less thans, greater than equals, less than or equals, and so forth. So keep in mind the right logic that you want to use based on the criteria. Scrolling down here, so the equality operator, the double equal sign, works great for integers and characters because keep in mind characters under the hood are typically represented as an integer, and that is the case in C++. So using the double equals on those types is fine. Now, you can use the double equals for floating point types. However, there's a problem with that. Under the hood, you are not guaranteed that two floating point numbers that you might think are the exact same actually are represented the same in memory. So we'll talk a little bit more later about how you should compare floats. Keep in mind, you can do it, but it is highly advised against. Do not check floating point types using the double equals operator. Also, the double equals operator works great for the string type, so it's going to check if the two strings are definitely equal. All right, let's go on to our next section that we're going to talk about, and this is 3.7. So these are called logical operators, and this is how we can put tested conditions together. So we have the and operator, the or operator, and the also not operator. So typically we're going to be using the and or operators. And the way that these work, again, just like in your previous programming classes, if you put two things together with and, that requires both of them to be true. So we've got a little truth table down here. So if I've got two criteria, in an and case, the only case that's going to spit out true when I put them together using and is if they're both true. And we can see that right here. If either one of them is false or if both of them are false, then put together this is a false. Now the or operator behaves this way. If any of the tested conditions are true, then it spits out a true. So you can see here that in these three value choices right here, at least one of them is a true, so it would spit out a true. In this case right here, these are both false. That's going to spit out a false. And then lastly, the not operator works like this. It's going to reverse the truth value of your statement. So if we had false, if we say not false, well, the opposite of false is true. And just like the opposite of not true is false. Typically, we might use the not in a case where we have an actual variable value. So we're using a variable to hold the status of something. And we'll see an example of that when we get to the bool data type here in a little bit. So the use of logical operators are great to detect ranges. So here we have to check whether a number is between 10 and 15. So what we can do is we can say, is x greater than 10? And then also at the same time, is x less than 15? So in code, we would write 10 less, in fact, do they have it in here? So they don't, so the logical operator is actually the double ampersand. They don't have that here. Where do they put that syntax at? Here it is. So the and is the double ampersand. The or operator is the double pipe symbol. So if I want to check if x is in the proper range, I say, is it greater than 10? And then I would replace the and in my code statement with the double ampersand. So x greater than 10 and x being less than 15. So you have to do both of these inequality statements separately. A common mistake new programmers make is they'll say 10 less than x less than 15, and that is not going to work. And then again, if I wanted to check if any condition was true, we would use the or operator with the double pipe. And so if I scroll down, so they have choices down here. So here's detecting ranges. I kind of like the explicit ones here versus the other ones here. And let's find an or example in here. I guess they don't have one. Here, I'll pull one up here real quick. So maybe we want to check if a number, so we might say, is x less than 0? Or x is greater than 100. So in a school setting, you can't have a negative score, and then you can't have a score greater than 100%. So we might check our valid ranges this way right here. Okay, let's go to our next section, which is section 3.10. And in here, we talk about the switch statement, which can be used in replacement of an if-else-if structure. So typically a switch and an if-else-if can be used interchangeably because their logic is the exact same. So for instance, we have a variable called a, and the values that can be associated with it go 0, 1, and 2. And if we have case 0, so the syntax is switch on the variable name, and it needs to be an integer type. So case 0, that's the value. We're going to print 0. Case 1, we print 1. Case 2, we print the number 2. And then this is a catch-all. So this would be like our else block. So this would be if a is equal to 0, else if a is equal to 1, else if a is equal to 2, and then else, here's our else block. Me personally, I don't care which way you go with it. I would probably just write an if-else if block because I would write that out very quickly. The other thing to point out with a switch block, however, is the usage of this break keyword. So the way that this works is it's just like an if-else if statement. It will find the first case that is true, and then the break breaks you out of that block of code. So without this break statement, so you do need to put this, if I did not put in this break statement, then it would continue on and it would print 0 and then it would print 1 and then it would print 2 and print unknown, but the break statement gets us out of it. Also, in terms of proper programming technique, is if you have a switch statement, then you need to have a default case handled and put the default case at the end. Okay, next section we talk about the Boolean data type. So the Boolean data type, or the bool, which is how we write it in C++, is a variable that can represent true or false. So we can see here that they've declared two bool variables. One is overweight, the other one is male. And typically the naming convention for a Boolean data type is an is something or has something. So that way it is read and it is very readable in code. So we'll come in here, and if user choice is equal to an M, so they typed in M, then you can see is male is true. Otherwise, the case is false. And then they have the variable is overweight, so they're going to check the user's BMI. So we enter that value, and if it's greater than or equal to 25, then we say that they are overweight. And then we can use those variable values with the different types of logic. So if I have two variables, is male and is overweight, then we have four possible choices. So we have is male and not overweight. So here's their life expectancy. If they're not male, that means they're female. If they're not overweight, then their life expectancy is going to be 83.5. So this is this criteria. If they're male and overweight, then the life expectancy is 77.3. Otherwise, the life expectancy is 81.4. So what is this criteria? So what situation does this put us in? So we have male, not overweight. This would be female, not overweight. So this would be a female overweight case. So a good practice might be to put the comment right here. This is female that is overweight. So that way it's easy to understand when you read the code. I do like the usage of a Boolean variable. It makes the code very clean. We could have written user BMI greater than or equal to 25 every place we see the overweight criteria, but that's duplicating code, and we don't want to duplicate code. So reference it using a Boolean variable, and then the code gets nice and clean. Okay, we jump to section 16, and I like the idea of these conditional expressions. The idea here is that we can turn an if-else statement from a block of code that has 1, 2, 3, 4 lines into one single line. So the idea is we check the condition. So right here, here's the condition. So we say condition gets checked, and you don't have to wrap this in parentheses. So whatever the condition is that you're testing, if it's true, this is the true case right here, then it gets assigned to the variable. Otherwise, that's the colon operator here, we would be grabbing the value of expression 2, and that then gets assigned to my variable. So these are two equivalent things here. Typically, I use this a lot when I'm writing code. If I only have two cases and it's a very simple condition, I'll write it as a conditional or a ternary operator. Excuse me. Now, one thing to note in Java and C++, the type that's returned here has to be the same data type. So if you're returning a string and the variable is a string variable, then expression 2 also has to be a string. Okay, in section 17, they talk about how do you actually compare floats, because we mentioned earlier that you should not compare floating point numbers or decimal type numbers using the double equals. So any float variable, any double variable, we should not use the double equals operator. And again, as it points out here, some floating point numbers just simply cannot be exactly represented. So they have a good example here where num meters, if you take 0.7 and subtract 0.4 and subtract 0.3, that should be 0, right? We've done the arithmetic. The 7 tenths minus 4 tenths minus 3 tenths is 0. However, inside the computer's memory, the way that a floating point number is represented, it could be this long string of zeros with some trailing values out here. So the solution that is offered to compare floating type numbers is that we're going to check the variable against the expected value. So we'll use subtraction, take its absolute value. So it means we had to import the math library, and then we check it against a tolerance. So if our tolerance is 1/1000th, so this is definitely less than 1/1000th, then we would be stating that this is a true value. So this is typically the way that you would handle the case of doubles and floats. Okay, last content for chapter 3, part 1 here is the idea of short circuit evaluation. So we saw earlier that we can use the and or operators, and the idea of short circuit evaluation is as you combine logical conditions, as you move left to right, and you use the double ampersand for and or the double pipe for or, if the first condition is not true here, so if this condition's not true, then it will not even try to test this condition right here. Okay, so this is really useful where you might want to check if something is a null pointer. So I check if it's a null pointer, and then I'm going to do something because I know it's not null and I can grab its value. They'll also state down here, so in an OR case, as it moves left to right, let's see if I can find an example in code. Here, in fact, I've got my little dummy example here from earlier. Let's say that the X value is -5. So when it comes in here, it would say, all right, you're -5, you're definitely less than 0. It does not check this other value here. It just checks this one. So a nice little feature, keep that in mind as you write the logic. If you don't write the logic properly, if you're trying to check something that is only going to be possible in this case, you probably don't have the right logic. Okay, that's it for chapter 3, part 1.